Taxi cab drives east. Drives east. So it really helps to draw a picture, obviously. Drives east 3 kilometers. So you know that this is 3 kilometers long. And then it turns north. And it's traveling right now at 50 kilometers an hour. 50 kilometers per hour. That's its rate of change, right? If you give these some names here, you might start by realizing that which things are changing in this situation. Which things are changing here? Let's give them some names. This can be X, Y, and D, or horizontal, or whatever you want to call that. We can think about some of the things that we know. Here's a starting point. Here's the taxi cab right here, right? There's the taxi cab. And you're getting ahead of yourself. The police one is later, okay? The police are not chasing the taxi cab, okay? Police are not chasing the taxi cab. The starting point is staying still. We just want this. This is increasing here, right? The distance is increasing. Which one is not changing? The X is not changing because it says they drove 3 kilometers east and then they turned north. This is changing. You're looking at how is the length of the hypotenuse changing relative to the other side. It's affected by several things. You have to write a formula for how the distances are related and then use that to find how the rates are related. So you can start by writing x squared plus y squared equals d squared. You can do it in this form, or you can change it to this, whatever you want. You'll get the same thing either way, but you might have to substitute something else. So let's do this both ways here and realize what's involved with both of the ways, depending on how you start. Okay. It probably helps to put in some constants first, or at least realize they are constants. Which thing is a constant here? This is constant, right? The fact that it's constant means when you differentiate both sides, it disappears, right? 0 plus 2y times dy dt equals 2d times d dt. dt. You notice that this is 0 here. You can just totally ignore it. You could then say you can divide by 2 because everything has a 2 there. So you can simplify it to y times dy dt equals d times dd dt. You could rearrange it. You could rearrange it if you wanted to. You could say y divided by d equals the other two rates divided by each other. If you want, you can isolate one of them. It's just like any other formula, and it has 4 things involved, 4 variables. That's a variable, that's a variable, that's a variable, and that's a variable. You can sub numbers in for any one of those 4 variables. You have to think about what you're given in this situation. How fast is the distance between the cab and the starting point increasing when the cab is driven 4 kilometers north? What things do I need to use this formula? You need to know the hypotenuse. So you could either figure out what the hypotenuse is at that instant, right? It has to be at that instant that it's driven 4 kilometers north. When we've got the fact that this is 3 kilometers, and we've got at this instant this is 4 kilometers north, and we've got the fact that this is going, what is this? This is plus 50 kilometers an hour. Why is it plus 50 and not minus 50? It's increasing, right? The distance is, y is getting longer. If you had something where it was going towards this corner point here, it would be, you'd have to call it negative, a negative value. So the values we have here, we have the y value at that instant is 4 kilometers, and we've got the rate of change of y is plus 50 kilometers per hour, right? And we've got, what do we have on the other side here? This is Yeah, we need to find out that, well, it's 3, 4, this is 5, right? You can work out that it's 5 kilometers. And then you can leave this, you can leave this as your value that you're looking for, right? This is dt. You can solve for that and you'll get what this is. Okay? You find out what that is. You should be able to use unit analysis and make sure it works. If you started with this formula, you'd get exactly the same thing, except that instead of this d here, well, you can try it and see what the difference is, which might be worth doing here. What do you get on this side? What's the derivative of square root of something? 1 over 2 square root of that thing, right? This is a constant here, so you could actually call this, 9, 3 squared, right, if you want. What's the derivative of that then? The inside, we need the chain rule. 2y dy dt equals d dt. The 2's cancel, right? 2's cancel. You get 1 over square root of 9 plus y squared times y times dy dt. This is exactly the same formula with 2 changes from the other side. Well, it's not. The only difference is this d is on the other side, right? Like if I put this d on the other side here, so we'll rewrite this down on the other over here, right? This formula that you have over here, let's move it over here. If you took that, I didn't actually want to take this, so we'll try again. Get rid of that. This thing, so we have this is on the other side, right? That's over here. It's 1 over that. And we have, instead of d, it's been replaced with what it's equal to, which in that triangle, what is it equal to? Square root of 3 squared plus y squared, right? The formula is exactly the same. You should be able to do it 2 ways and get exactly the same thing, right? This formula is different in that, well, it doesn't involve that you know anything about the distance in between, because maybe you couldn't measure that in this real situation, right? Maybe the only things you can actually measure are the horizontal and vertical distances. Probably if you're driving your car, you can measure that, you can measure this, but this you couldn't really measure. So maybe that second formula we generated is actually a better formula, because all you need to know is how far north you've traveled. Okay, it involves one less variable. Okay, does that make sense to you? If you come up with a formula and then you think, wait a sec, I don't have the right variables to use here, you can always make those kind of changes. Are we okay with that? There's a lot of things involving Pythagoras here. There's the bug walking. You need to think about which ones are changing. In this situation, this was fixed. In other situations, the hypotenuse is fixed. Sometimes the vertical line is fixed. You could make one where all 3 of them are changing. Okay, you just have to think about what's happening. I would like to tell you about this one. Storybook time. It's not